Hello there again. In our last video of the same lesson, we were finding the adjoint of our supposed matrix A, a 3 by 3 matrix, and I've taken the liberty to draw it up again, to write it again here at the top. And in this video, we're going to be finding the determinant of the matrix A so that we can be able to find the inverse of our matrix A. So I'm going to try as best as I can to explain the step for finding the determinant of A. Believe it or not, the determinant of A is linked to the adjoint of A. You can find the determinant of A from the adjoint, and there are numerous ways to find this solution, and all these solutions will be the same provided you do the mathematics correctly. So if you given your adjoint here, if you first multiply all the members here with their original element, say here the original element for this one was A, for this one was B, C, and so on. If you multiply them for each column or for each row or each column, you multiply those elements and then you add together all the members of a row or a column, then you should get the determinant. So that means we can have more than one way of finding the determinant. The answer will always be the same. So I'm just going to demonstrate it here with the blue pen. The determinant of A, meaning it can have many ways of arriving to the same answer. So it can be A multiplied by EI minus FH minus B multiplied by BI minus CH plus C multiplied by BF minus CE. That's going to give you the determinant. That simply gives you the determinant using the first row. You can use the second row. Again, it's going to be the same answer. You can say minus D multiplied by DI minus FG plus, I think that was E in there, and then we're going to get AI minus CG minus, oh sorry about that, and we're going to have there I think it was F here, yeah, okay, F multiplied by AF minus CD. So this is also the determinant. If we were using numbers instead of letters, this would simplify to that the answer you would get there, they would all become the same. So you can find your determinant either from this column, that column, that column, and that column, that row, and this row. So meaning in total you're gonna have 9 solutions. It is highly discouraged that you use the diagonals, so you should not use the diagonals. Try this is incorrect. Well, at times it happens by complete coincidence that the determinant is true, but most times it will be wrong. So you go with the rows and the columns, and that's how you find the determinant. So you can try it out for this row or that row, or for this column or that column. You will still get the same answer of the determinant. And now we can conclude our video. We can record time, and that our inverse of A, which you say A to the minus 1, is equals to the adjoint, which we found up there, of A over the determinant of A. And we're going to do an example in the next video where we're going to be using numbers, and we're going to be taking the same steps to find our inverse of a 3 by 3 matrix. Thank you so much.